right. Hi, everyone. I'm Dr. Vishu Gupta, Head of Research at TensaX Innovation Lab. And let's get started with our online event today, which is Career in Artificial Intelligence. I'd like to welcome all the participants, those who are joining us again since our last webinar, and those who are jumping into the world of artificial intelligence with us today for the first time. A couple of things. Our main goal today here is to just explore the career opportunities that artificial intelligence presents in different sectors that are available, right? So we'll kind of touch over the sectors, the jobs, as well as a basic knowledge base that is required. If at any time you have any questions, just feel free to drop it in the chat box, the button for which should be at the bottom of your screen, and we'll get to it towards the end of our presentation. All right, so everybody's just ready to go? Excellent. So what I'd like to do first is introduce Mr. Aryan Singh, our Chief Technology Officer at TensaX Innovation Lab. Hi, Aryan.
Hello all, and welcome to Career in Artificial Intelligence. Let's get started straight away. So to get into artificial intelligence, let's first define what is artificial intelligence. Imagine a world where all of the monotonous tasks are taken care of by artificial intelligence algorithms. All the things that you don't like to do, or all the processes which are repetitive, all the processes are assisted, augmented, and automated by artificial intelligence. To define artificial intelligence, let's first look at intelligence. Intelligence is the ability to understand, reason, make sense of one's environment, and then make decisions, accomplish tasks. And artificial intelligence is the ability of algorithms, machines, and computer systems to mimic the same, to operate like human intelligence. You may already have some ideas when it comes to artificial intelligence already in your mind. And those ideas may look something like this. These are coming from sci-fi movies or, different literature you might have consumed about artificial intelligence. But practically, we're already surrounded by artificial intelligence. And here are some of the examples. So you have all the virtual assistants. These are natural language models. These are Siri, Alexa, Google Assistant. Then you have Tesla with their self-driving cars. Now, this algorithm is a conglomerate of multiple algorithms working together and predicting other cars and then taking decisions on where to drive the car. Then you have all the social media networks. They have their recommendation engines and they have their facial recognition systems so that they track who is there in a particular shot. This is Facebook. And then you have Google. You have Google services like Google Translate and others. And then you have Google Search itself, which is a language model, and it indexes, it reads a lot of pages, and then it filters, and then it performs, it computes an index, and then it performs the search for you. Since 2016, there's been a rapid increase in the adoption of artificial intelligence. And we're going to see the graphs now. If you see, since 2016, AI startups and the business AI startups have accumulated, that has gone up significantly. And that was the trend till 2019. And in 2020, when the pandemic hit, even then, 30% of the organizations actually plan to increase AI investments. And this trend is going to continue after 2020. Here are some projections. AI is going to, we've only scratched the surface, and it's going to apply to every single field that we know of. The augmentation of processes, the automation of processes, and creating systems which help people do more tasks. When we're going to enter the workforce, as in students, we're going to use artificial intelligence tools. We're going to be surrounded by such tools, and they're going to help us do our work processes. They're going to help us automate our workflows. They're going to help us do more work, get more work done. And the work that we do, it's going to get rid of the monotonous, boring work and It's going to help us get the work done faster and in an easier way. Here are all the sectors, technological sectors in which AI is going to grow. And this is how much it's projected to contribute to all of these sectors. So you have image recognition, image classification, and tagging. So if you talk of all the social media applications, that's that. And then even in the when you work with documents, when you want to have any automation, let's say reading letters and then simplifying letters for simple processing of them, that's all image processing. And then any automation in any workflow, there's that. And these are all the sectors in which AI is going to contribute, and this is how much it's projected to contribute. Now, the thing about this graph is the projections are rising continually, and those are rising exponentially because we're coming up with new research and we're coming up with new applications as we're discovering them. And it's going to be everywhere. These are all the sectors and the different regions where AI is going to contribute. And as you can see, it's practically everything, from agriculture to production to tertiary activities and services. It's going to be everywhere.
So if we talk about these sectors, it's practically all of science, all of engineering, all of education and finance, right? Normally, we don't talk about artificial intelligence in these sectors, but what we have to realize that AI is penetrating all of these markets, and not just penetrating the market, it's actually creating job niches in each one of them. So this is something that we should explore a little more. And, this is anybody who's looking into artificial intelligence as part of their career growth, you have to realize that there are a lot of sectors that you can apply artificial intelligence to.
Yes, and if we talk of why AI adoption has been rising, there are three main contributing factors. There's been a lot of new research since 2016, and these research papers, these researchers have helped us do more. Now AI has practical applications like recognizing faces or helping us take a better picture by, we all have AI models running in our camera applications of our phones, filters on social media, or automation of any process, like in a factory, classifying different things and then segmenting them, sorting them. The new researchers have helped us to do all of that. And then to train these algorithms, we've had an influx of data that's being generated. Everything, there are sensors in everything, and now we're getting the data from all of the things. Your phone is tracking a lot of information about you, and though that data goes to Google, and then Google makes different models. And likewise, all the services that we use, the data is being generated, and using this data, this insight is being generated, and then new AI models are created. There's also been a rise in the computing power that we have available. In the late 1960s, when they sent people to the moon, they only had as much computing power as a calculator, like a high school level calculator. But now we have a lot more, and that's also going to increase. So all these factors together have made AI adoption grow. And it's not just research, it's already there in everyday life. If we talk about this, everything that we do on our phone, all the things that we do on a day-to-day basis, like writing emails or replying to texts or clicking pictures or communicating with people, AI would help us in do all of that. It'll help us make those tasks easier, help us do more of them, and make the process of getting those tasks done easier.
I mean, even if we talk about it right now, correct? Something as simple as route suggestions. This is something all of us are currently using. If you search a location on Google Maps, right, it gives you multiple options. It also shows you what the traffic condition is on a particular route. And then it also explains how long it would take to get there, right? All of this is a prime example of how artificial intelligence is actually already ingrained in the functioning of our phone.
Mm-hmm. And it's not just technology sectors where AI is in. If you look at this picture, you would see that there are endless names, and more. Here are some more names. These are the services that we're already using. This is Netflix with their recommendation engine. It recommends you what to watch next. Amazon with their recommendation engine, recommending you products. And then there are services which AI runs on. These are these different places where we host AI models. And then there are the research frameworks and tools. So it's the entire AI ecosystem. And then this entire thing applies to not just within technology, it applies to actual processes of the world, actual tasks that we do, all the things that we do practically. Here are more names, and these names are just going to, they're going to be more and more and more. There's also been a growth in the number of jobs since AI has come out. Here are the share of US jobs requiring AI skills. So what's going to happen is, in a few years, we're going to use AI tools everywhere. Let's say we have to write an email. AI tools would help us write an email. So it's very much required that we understand AI. A lot of companies in Silicon Valley, they're experimenting with different AI models, and so are many other places in the world. And these AI tools are going to be part of the workflow. There's been a rise in the number of AI and ML jobs. And this has been the trend since 2019 and 2020, the pandemic hit. And now this is only going to grow and only going to grow faster. Revenues from companies and startups incorporating AI, they've also been on the rise. And it's projected to be a lot higher, because when the processes are automated and people are not doing repetitive, monotonous tasks, people can do more. And it makes the working environment better. It makes it more intuitive. So those companies would have a higher efficiency, higher performance, and then higher returns. And then they're going to hire more and do more. AI job postings have also been on the rise. Since 2016, it's been growing up continually, and it's in different sectors altogether. Also, the salaries for people working in AI, that have been the highest in the computer science industry. Arguably, sometimes even the entire engineering industry. This is the median salary of average salary of ML engineers, data scientists, computer vision engineers, data warehouse architect, and algorithm engineers in the US. And this is in other countries. Even in India, if you compare it to someone in web development or other skills, just because AI is so scarce, and the value that it brings forward for companies, the different processes, the workflows, AI engineers, AI developers, AI designers, they are paid a lot more than other tech developers right now. And I think this trend is going to continue. In 2017, I was taking a course at Stanford University where I started artificial intelligence. I saw AI being applied in different sectors, and Stanford University is the world's #2 ranked university in computer science, and it's just 12 kilometers away from Silicon Valley. And Silicon Valley is the place where a lot of companies who started to adopt artificial intelligence and a lot of companies who started to adopt new technologies, they started. And in 2018, I was at MIT, and I was there at CCEL. CCEL is MIT's Computer Science and Artificial Intelligence Lab. And these are the few professors I work with. So I was there and I was studying how AI is applying to different fields and how it's growing. Another professor that I work with at CCEL, another professor. And from there, I saw that internationally, this is what is happening in the world. And so has been the trend in India as well, and just everywhere. These are the different sectors in which AI applies to, and jobs in these particular sectors have been growing. So if you talk of information, it's data science and generating insights from and generating business intelligence, professional services, and these are the different automations that are being created. Finance and insurance, that's AI in fintech, and so on. There are going to be jobs that are going to grow. And if you realize, these are all the things that are related to artificial intelligence and artificial intelligence with emerging technologies. And as AI is going to come over here, it's going to create more jobs than it's going to take. But the jobs which are monotonous and were repetitive and boring, it's going to reduce those jobs. So it's a positive change there too.
That is something important that we probably should we have misconceptions about, is that artificial intelligence is going to steal jobs from other sectors, which is definitely not the case. What it's doing is that it's adding more intelligent jobs to the market, instead of just having people work at redundant jobs or repetitive jobs. It's more about applying their skill to a more intelligent aspect of the work.
Artificial intelligence is the fourth industrial revolution. You can say that it's the next big thing. And why we say that is because in the first industrial revolution, we had mechanization and the factories. And then we had mass production lines, we had electricity. The third industrial revolution, we had computers, the internet, the influx of connectivity and the information. And the fourth industrial revolution is going to be the automation of intelligence, the automation of people who were just who were doing repetitive jobs, just running those machines. Now AI can run those machines, and people can do what they're good at, the creative things, the more intuitive things. And this automation of intelligence is the next industrial revolution that's going to be there. When we talk of jobs being restructured, there's this thing that comes in, which is called universal basic income. It's the idea that people who are not in AI and whose jobs are restructured, they would be given a monthly set monthly income, and everyone's going to be given a set monthly income. And these are the trials of such programs that have happened worldwide. India also had such a trial, and internationally there have been many trials. These were the results of such trials.
So when we talk about this experiment, right, what we see, it's been tried all over the world, right? That's what we were looking at in our map. If we get back to it, there we go. So we can see that all over the world, we have something going on. Places, we find this to be more of an abstract concept that it hasn't been implemented. But looking at this map, in fact, not only are they planned or ongoing, in certain places, they've already been completed. Right, and what do we see from these results? Right, we have different levels of responses from the recipients who have worked with, who've been taking a basic income. Right, basically what it's doing is it's handing out a certain amount of the money to people based on their skill and everything else. Right. However, the recipients, if you look at this very first top left thing that says recipients of basic income, you can kind of see that about a decent number is living comfortably, and a majority is actually doing okay with that. So as we try, but what's going to happen is the more we try this out, more is it going to become more efficient. It's going to help everyone out. It's a matter of a little bit changing the perception that is associated with this concept. So as Aryan said, this is AI is the next big thing, right? So sometimes it's also at the border of the fifth industrial revolution, right? So what we are leading towards, we're going to completely towards automation here, right? Adoption of the application into different sectors. We looked at all the different sectors where artificial intelligence is integrating. And although the jobs for computer science engineers and designers has gone up the most, we do have to realize that for every other sector, for technologists, for agriculturists as well, the application of artificial intelligence has increased, and consequently, the jobs related with AI in their respective sector have also seen an increase. So this does not mean that only computer science engineers or somebody can apply artificial intelligence in their area. It's also other sectors, and I'm specifically talking with an example as myself, because I am an electrical engineer, and I use artificial intelligence in different parts of my projects that I've worked on and I'm currently working on. So artificial intelligence is not something that is not going to integrate into everything. As a next major thing, it's going to actually lead us into the fifth industrial revolution.
And this is what the consequence of that: universal basic income and people doing the things that they are best at. At the moment, people trade their time for money. So they do something, many people do something they don't like, and they trade their time for money. And AI is going to change that. And it's going to be there and everywhere. And it's initially, as that is happening, it's going to create more jobs. And with universal basic income, this is how the job change is going to look like. There are going to be less people doing repetitive things and more people doing the more humanly things. And people who are in artificial intelligence, they are going to be the most advantageous. They are going to be the ones who would be making the different automations, the different things, the different tools that are going to help people do the jobs better, that are going to help ease. First of all, it's going to ease all the processes. Like, for example, whether it's mechanical automation, robotic process automation, or any workflow, AI would help us get rid of all the repetitive parts of the processes. And the AI developers, the AI designers, they're going to make these things, and they are going to be the highest in demand. Now, let's talk about what do we need to get started with a career in AI. You need knowledge, you need skills, and then you need a portfolio of projects so that you all in all have a well-rounded profile. We're going to talk of all of these AI skills and where you're going to get them. If we see all those AI models, they can be plotted on one spectrum. Right now, we are in the phase of artificial narrow intelligence. We are making tools that these AI models solve one problem and they excel in one area, whether it is recognizing faces or recognizing speech or doing text to speech or any one specific task. And we are headed towards artificial general intelligence. At that stage, you would just be able to tell an AI, okay, go do this, and the AI would understand all human parameters and it would help you do more. And we're far away from that, but we would get there soon. These are the three types that we talked of. Right now, we're in artificial narrow intelligence.
So let's talk about some of the skills that artificial intelligence deals with today, right? Right now, if we take a simple example of the applications around us, what we see is that AI understands basic inputs, right? We do speech to text, there's natural language processing, and then what does it do once it's taken those inputs? It manages the knowledge. Based on that, it executes a certain task. It gives a certain output, right? But in the middle, what happens that AI also learns. So when it receives a new kind of an input, it is able to process that as well and take the consequent output as for that, right? So let's talk about something as simple as image recognition or Google Maps. If you look into that, it understands the basic input. Let's stick with the maps, right? We used that example a little bit before, so we'll just go into that again. It takes your input, locations that you send. It manages the existing knowledge it has. It considers all the location parameters, and then it executes a task. It shows you one route. However, since it has learned from your inputs before, it has learned the new data that is available in terms of traffic and everything, it is able to enhance its knowledge. And then the next time you go for the same location, it's actually going to give you, it may give you a revised option in terms of a better route that has less traffic or is faster, right? So we have different segments of the skill that artificial intelligence has today.
If you look at this graph now, we talked of the term learning. So an AI learns from its environment, and this is a difference. The term machine learning comes here. And how it's different from traditional rule-based systems is, previously we used to feed a rule. Now you can't feed rules for recognizing images or complex things because you can't abstract to that point. So which is where machine learning, the term machine learning comes in. So you make an algorithm, and that algorithm, you give it a lot of data to learn from, and then the algorithm makes its own rules. It learns from the data. And these are the terms you might have heard in this domain. There's artificial intelligence, there's machine learning and deep learning. So machine learning is a subset of artificial intelligence. All AI models are, many of the models that we use, they learn from their environment, and that aspect of AI, that is machine learning. You might have also heard of deep learning. Deep learning are these models that are really good at images and speech. And these are these really large models. So they have a lot of nodes and a lot of detail in the definition of the model. And it's a big model, and it learns on a lot of data, which is why it's called deep learning. And data science overlaps with it. A lot of the data processing that we do in making these models and the intelligence that we incorporate whilst working with the data, an AI works and learns on the data that it's fed. That is data science. Data science is also visualization, plotting, and making presentations, and so on. These are different sectors in which AI applies. Like we saw in the graph, AI has multiple applications in all of these sectors, and many of these applications we're going to touch on later in our presentation.
There's a lot to go over, right? There's so many applications that we have. We'll go over a few in detail, as Aryan said, towards the end of our presentation, but let's touch on a couple of those right now, right? Let's talk about food technology. Now, food technology is something that we don't really consider AI integrating itself into. However, food technology basically refers can be segmented into two different parts, right? One of that is delivery, what we deal with, when you order food over Zomato or Swiggy or Uber Eats or something, right? And it is delivered to you, right? That whole process is automated. That also has artificial intelligence in it, based on your recommendations, based on the recommendations you receive to order a certain thing from a certain place. All of that is artificial intelligence. Now, the second part of food technology is the actual agriculture aspect of it. Even there, artificial intelligence can do wonders, because agriculture or food growth is dependent on a lot of factors, right? So let's consider weather for one thing. If we have better weather predicting capabilities, that is something that would help us plan out our crops, especially in areas where all of food production is dependent on rainwater, right? So something like that, artificial intelligence would be something that can help us there. Travel is something that we are already using artificial intelligence in. You are getting, again, a recommendation system that is suggesting actually where to travel based on your input parameters. And there's n number of places that, n number of applications that we can discuss for artificial intelligence. So we're going to get to more of those as we go through this presentation. But let's get into machine learning now. As Aryan just discussed, machine learning is kind of what powers artificial intelligence, right? Before we jump into that, let's kind of just briefly go over the industry approach that we generally take, right? Just to give a brief blockish overview, we usually go with, we identify the problem, determine what we kind of need to do. We collaborate with the field expertise, and we collect the real data, right? There's a lot of things that we're going to discuss about data again. And based on the data that we have, based on the inputs that we have, we refine our ideology and work on prototyping a solution eventually, right? There's a whole process that goes on within the industry. However, what you're not seeing here, you're seeing big blocks here, but what you're not seeing is artificial intelligence being applied anywhere, right? We haven't created a specific block for it. But what we have to now realize that artificial intelligence actually ends up supporting every single part of this whole approach.
And also how this, let's say we're working on one AI project, how it's going to be, let's say we've identified a problem. Okay, let's say we're going to make a model that recognizes diabetes and through diabetic retinopathy. So like a mathematician working on a math problem, first of all, we identify all the variables that the problem depends upon. Whether it be in building an image classifier or building a reinforcement learning model for a factory or something else. We get all the factors that the results depend upon, and so that we know all the variables that we're working with. Then let's say we're making a model in the medical industry, then we collaborate with field expertise, which in that case would be with doctors. We collaborate with doctors, or we collaborate with any expert in the industry who can help us make sense of the features in the data. Then we get data from these experts. Let's say if it's a model in the medical industry, we get data from clinics or somewhere else, obviously taking care of all the privacy requirements and everything. Or let's say we're working for some automation in a factory. We get data from the machines, from the different processes, from all the things that we discussed upon with the industry expert. When we have that, we model the data, we clean the data, we make models on the data, we prototype, and we continually integrate and continuously improve iteration by iteration. And then we package it in an app, we test it, we do beta tests, and then we roll something out. If we see how ML goes from its design to its development to its deployment, we'll talk about all of these here. First of all, you have to think like a data scientist. You have to understand the root of the problem. Again, identifying the features, all the variables that the problem is affected by, that it depends upon. Let's say affecting something that affects the problem and your data set doesn't reflect that. You should collaborate with industry experts and think like a mathematician and a data scientist to think of all the factors that the results are dependent upon. And then you get data that is in sync and that reflects all the conditions and all the features that you're going to need to solve the problem. One has to think in an unbiased way, and they have to be good with using different tactics to clean up the data, using different tactics to see the trends in data, and then refining those trends. And then they must know the different models that they can use, how they can get to the best model architectures, how they can tune their hyperparameters. All of this is not complex. All of this can be learned. And the thing is, all of this can be learned in a matter of 3 months. We've done that at our lab, and that's possible.
Absolutely, I agree. It's something that goes on at TensaX Innovation Lab. We have our interns that join us for our programs, and we do kind of go through the program in teaching them how to start from the very beginning, where we understand the problem, and all the way to understanding data and utilizing it to apply to an application.
Mm-hmm. And then we use different frameworks to build a deployable ML model, and then we deploy it either on the cloud or mobile devices. And all of these things we do at our lab, and we have trained many people to do it. And that also, we've seen that, the whole process of getting people who are interested, getting them trained and getting them to build projects, it doesn't take a lot of time. It may sound complex, but all in all, it can be covered, and we've seen that.
Yes.
So the first part of building such models, the first part which comes is collecting data.
All right, collecting the data, the basic thing that we need to do to get started with our ML models, right? So before that, let's quickly review what different types of data we have. We have primary data and we have secondary data. Primary data is essentially the data that you collect directly, right? So you've taken a survey, that becomes primary data. It's being collected for the very first time for that application or in those parameter sets. It's automatically considered to be original and is more reliable. Now, secondary data is consequently, something that you are collecting from somewhere else. It's secondhand information. It's obtained from different sources. But what the benefit here is that primary data is difficult to collect, right? Each person cannot collect data on every aspect of this world. So secondary data is generally where we end up dealing with for our machine learning models.
Let's talk of a few examples. So when we talk of directly collecting the data, that would be at our lab, we've taken, when we were making a body language classification model, we had our volunteers and we took 300 pictures, and then we augmented that data set to make it 1,000 pictures. But collecting data yourself, let's say taking pictures or recording voice samples or taking any sensory input from somewhere, that's primary collection. It would, if you're working with an industry expert, let's say you're working in a factory and you've set up the data collection protocols, that's you collecting the data yourself. Secondary would mean you've picked up an online data set and someone else has defined the metrics, someone else has procured the data, someone else has done all the management and the organization of how to arrange the data and everything. You're using internet data sets or you're getting it from a third-party source, that's secondary data collection.
That is indeed. But the benefit comes in when you have both primary and secondary data, right? You can always, more data is always a good thing. Well, to an extent, we'll get to that as well. But let's talk about how you can get secondary data, right? You can get it directly from the primary collectors. If you know somebody who has collected the data or it's a certain data type, as Aryan just mentioned, you can always request them to share that data. There are a number of online data resources that exist, and we'll share a few down the presentation. There are online data repositories. There are databases that you can essentially access free of cost and get the data that you would need. Of course, there are published resources such as books and papers that appear in a number of journals that you can utilize for data as well. Then a lot of people, instead of sharing the data on data repositories or database, they have their personalized blogs and websites where they share the data that they have collected. So it becomes secondary for us, but we just have to take permission, and essentially we can use that data as well. And of course, the deep records that the government has on a lot of things become a really good source for us for data collection, for obtaining data that we may not otherwise have. right? So here are some examples of where we can get data. We have Kaggle and
Just a point.
Sorry.
There are a lot of sources that we can get this data from. So when we talk of primary collectors, there are a lot of universities and institutions that conduct a lot of research, and they create data sets and the models that they create. Even private organizations, including large and big organizations, even Microsoft. Microsoft conducted an experiment to classify facial microexpressions, and we got 30,000 images from them. Then there are governments have their own data portals. India has data.gov.in, and all of these factors combined, there are a lot of places where you can get data from. And talking about this, you have this website called Kaggle, and it hosts these competitions where they post data sets and they invite people to build and model, and then they have a reward for that. So people can go and try out Kaggle competitions. There are a lot of people who participate, and the people who win, they get a reward, and people compete over there. So Kaggle hosts a lot of data sets. Also, there's this extension on Google Chrome. It's called FATCA Batch Image Downloader. And let's say you want to make an image classifier that classifies cats. So you search for cat, and then you use this extension to download. You can now batch download all of the images from there. There's the government data platform, which is data.gov.in. There are also private data sets like the one was with Microsoft. And you can also scrap images from different websites, different blogs that people have posted. And there are Python tools for you to do all of that. You can, at the last stage, you can also generate data yourself, like clicking your own pictures or recording your own voice samples. And yeah.
So it all comes down to the type of data that you need, right? So explore all of these resources when you're looking for data, and hopefully, actually, in all probability, you'll find something that works for your project. So now let's talk about playing with the data, right? Once you have the data, what to do with it? Before you put it into your model, you kind of have to play around with it a little bit. When we talk about data, we also have to consider biases. There are biases that exist in data. What is meant by a bias is that sometimes what happens when we're collecting data, a particular type of data features more often than the other. So for example, if we're looking at image collection data of a lot of people, it might be that black-haired people have appeared a lot more. So our model would be biased towards black-haired people, right? So kind of to talk about that, we have to visualize how our data is performing before we actually put it into our model.
Mm-hmm. And we have to, there are a lot of things that we can do to visualize our data.
Yes, there's actually a lot. So what we were talking about, biases in data can be seen easily when we visualize it. There's a distinct benefit that comes along with using a graphical or some other form of approach for our data, right? It's data visualization essentially is presentation of data in a graphical or a pictorial form, right? The benefits that it gives us, it lets us identify initial patterns that exist. It lets us determine whether there are any outliers or, anomalies that exist in our data. We can initially, at an initial stage, evaluate what influencing factors are there in the data and how we want to approach the problem with those influencing factors. And then we can explore what the priority areas would be. Of course, when we are looking at all these 4 advantages, what we can also determine here is that if there is any biases that exist within our data. So there are different factors that influence how you're going to visualize that data, right? You have to first think about what is the purpose of visualization, right? What do you want to actually see with your data? Do you want to see how it varies with time? Maybe you want to see there are multiple different factors, right? Maybe you want to see how they relate with each other. Or you want to compare how 2 or 3 of these factors are performing in a particular set. So that becomes your purpose that lets you define how to, why you want to see your data. Then you have to think about the type of data that you have, right? What is the nature of it? Is it varying with time? Is it qualitative data or is it quantitative data? And then, of course, you have to think about the audience that you are aiming for. Who is going to see your data, right? We all have different levels, different things that we want to see with our data. So you have to think about it that way. So for a product user, your visualization choices would be different. For a researcher, it would be, again, a little more detailed in terms of certain factors based on what they want to analyze, based on what you want to analyze. And for a decision maker, the data visualization becomes different entirely. So these three broad areas of purpose, the type of data that you have, and the audience that you are targeting become important factors that that basically govern how you're going to represent that data.
And this data visualization exercise helps you to identify which features affect the results of your model, which features affect the results of the problem that you're trying to solve. And you'd be able to see where your data needs to be cleaned, where your data needs to be processed, where your data needs more clarity, and what are the different features that you need to account for when you would be modeling and creating a model out of your data. These are the different tools that are being used to do that. There's Tableau. Tableau is a software that you can download right now, and it's used for a lot of different visualizations, and it is free. There's also Matplotlib and Plotly. These are Python libraries. So Matplotlib is for more basic plots. These are some of the plots that Matplotlib has generated, and it's good for basic plots when you want to plot something really quickly. There's also Plotly. I consider Plotly as like Matplotlib, but cleaner and sort of more neat and more aesthetically pleasing. Both of these are Python libraries that can be used to visualize your data. And we use them repeatedly when we're trying to visualize your data. These are the different plots that we can use to visualize the data.
Yes, again, it comes back to what kind of data you have and what you want to see, right? And so one way to do that is a simple line plot. This is something that you'll see most commonly in data visualization, data graphs and everything. It's just a single line, simple plot. Here's a simple code for it that you can kind of use. This is the most common one that you see. If you think about it in engineering terms, it becomes an XY plot. That's basically what it is. Then you can have, multiple subplots as well, showcasing the data in two single line or multi-line plots in two different windows. Then we have scatter plots. Now, scatter plots are fun, right? As you can see in this particular graph, it lets you showcase multiple data when it comes to in a single window.
You can use them to show the distribution, and you can study the distribution of different things and how densely they are at a particular point. And then you can see whether any feature has correlation with the result you're trying to get to solve your problem. There are histograms that show you the different the variation in things and how what's the what's the probability of occurrence at a particular data point. And data science covers a lot of statistics. And when, let's say any of you is joining to work with us, we'll go over these terms, and it's not that complex. There are bar charts which can compare the different values of different points of data. And then there are pie charts which can represent data in a simple, easier to understand format, and see, how much of a particular thing composes the subject. There are a lot of things we do to clean the data. There is this thing called batch normalization. Let's say your data is not on the same scale. let's say you're working with two different variables, and one variable is on a completely different scale than the other. Modeling the both would be hard to do. Let me tell you how this practically applies. Let's say when you take a picture, you see how sometimes you can tap on the screen and then make it brighter or darker. If some images are darker and some images are lighter, but they have the same features, you have to get them on the same exposure level. And that would be batch normalization for images. And let's say you're working with if you're working with one-dimensional data out of a sensor, any sensor in a factory, or speech or anything else, if one speech sample is louder and another is quieter, you get them on the same scale so that it gets easier for your model to be trained on. Let's say you have 3,000 images, but you want to create more. These deep learning models perform a lot better when you have more data. Then we use something known as data augmentation. So you can scale, rotate, skew, make them larger, make them smaller, and make multiple images out of less number of images. So this is the image of the cat that you see over there. It's just one image of the cat, and see how many images we've made of the cat. This is from the dataset MNIST, which is a handwritten character recognition dataset. And this is someone who's drawn a 6. And this is how many images of the character 6 we've produced. So when we have more data, our model performs a lot better, because in realistic conditions, the character 6 can be written like this. It can also be tilted. It can be smaller or larger, but our model should be able to classify that. So we use data augmentation to create the different variations that the model is going to see, and we generate more data out of the data set we already have. For a lot of classification models, we do something known as feature extraction. Like you can see over here, let's say if we were classifying horses, then we can segment the scene out, and then we can look at the different features of the horse. Let's say if it has a particular color or particular type, and we were to classify what type of horse it was, all the other features in the image, the background, the other subjects in the scene, they're not relevant to us. So we can use something known as image segmentation, and image segmentation is of two types. Like you can use semantic segmentation or instantic segmentation. These are basically whether you want to label everything as a separate object individually. Like if you see 5 people, you want to name them as person 1, 2, 3, 4, 5, or people as one domain. So over here, we're going to use semantic segmentation. We're going to take a horse out, and then we can look at the features of the horse. Many a times we do feature extraction for specific image classification applications. Also for speech, there could be a lot of background noises. Like there could be a fan in the background or something else. And when we are trying to train a model, we can use speech segmentation. This is all in all, the umbrella term would be for us trying to take out the relevant features. It's called feature extraction. We can also use a strategy known as generative training. There are these models which are called generative adversarial networks. And when you train them on a type of images, they can generate similar images, which are new and different, but are similar to the ones that the model is trained on. So we can generate more images using GANs or generative adversarial networks. This is another AI model which is used in the training process to generate more data so that we have more data to train our base AI model on. There are many different libraries that we use for pre-processing. These are 2 in Python. We use NumPy. NumPy allows us to make arrays and do a lot of different math operations in Python, and also SciPy. Now, how do you decide which model architecture to use? Like either you can see first of all, you got to see what type of data you're working with. And then let's say if the resolution of the images is larger, then you're going to use a different architecture. If the images are recurrent in nature, Then you can use RNNs, a specific type of model. So, well, short answer, there isn't a protocol for finding out the perfect model architecture. You can try different models and then see which one works best. You can see, you can read research papers and see how different researchers in the past have used different algorithms and how they've performed, and if their problem is similar to yours. You can also, there's this thing called neural architecture search, where you use genetic algorithms to tune the architecture of your model and the hyperparameters. Hyperparameters are the tuning, the adjustments that you make to when you're training your model. And so let me explain a little bit about how neural architecture search works. Finding out the best architecture for your model is also something that you can do. It's like mathematics, and it's a permutation combination game. So you can use another machine learning model to optimize your machine learning model that you're trying to create to solve a problem. One way to do that is genetic algorithms. Let's say you start out with one model, and then the algorithm makes different variations of the model. Let's say one with more nodes, one with more layers, one with less layers, one with different parameters, different hyperparameters, and then it simulates all of them. And like biological evolution, the parameters, the tunings which are doing better, those are carried on, and then it makes further adjustments to based on the parameters that are performing well. And all in all, after many generations, we get to the best architectures or the best tuning of hyperparameters for our model. Let's explore more machine learning concepts, different ideas that we talked of, and how they are practically implemented, and how what they're composed of and how they are run. Let's start with image classification as an example, or we'll talk of how that applies. We touched upon the term called deep learning, and those models are called deep neural networks. They're used a lot in the industry nowadays. A lot of models that we use on an everyday basis, they are deep neural nets. You might have seen a model that looks something like this. So you have a lot of dots, and we'll explain what these dots are. All of these dots are called a perceptron, and they take the input of the previous layer, and they summarize it, and they pass it on to the next layer. And all of these put together makes a deep neural network. Why they're called a deep neural network is because there can be thousands of these nodes. And each perceptron is a weighted sum of the last layer. And to get them on the same scale, we use something known as an activation function. When we add them all up, the results are not on the same scale. So this activation function gets them on the scale of 0 to 1, or in some cases, -1 to 1. These are different activation functions that we use. I'll explain in a brief sense what all of these terms mean. This is in relation to images. An image is a two-dimensional array. So you have, when it's a colored image, you have the three channels, red, green, and blue. And you have two-dimensional arrays of red, green, and blue, which make up all of these images. So you have these different convolution layers that simplify the image, and then it passes on to the deep neural network, deep layers, dense layers. These are called dense layers, and those layers look like this. Now, our goal is to train the model such that when the image passes through the model, and let's say we're classifying for the letter 0, all those nodes are adjusted so that when 0 is passed on the model, when you multiply them, if 0 passes on to a model whose parameters in sequence multiplication are arranged so that this image is passed on, a higher probability would be a higher confidence score, a higher probability would be generated when 0 is passed on. So when it is trained, when we're training, we label these images. We say, okay, this is 0, this is 1, this is 2, this is, and then we train the model. And then what we're doing when we're training the model is that we are adjusting the value of all of these dots that you're seeing over here. When we do that and the model is trained, this is how all of those these convolutional, the values, when we visualize them, how these values are going to look. So when you now pass a 0 through this model, 0 would mean that there's a lighted pixel over here, lighted pixel over here, lighted pixel over here. And when 0 passes through this model, it would produce a higher score. And when there are pixels over here, it would produce so blue means positive values and red means negative values. And when the image would be passed on through this model, these filters, when it would multiply, it would be multiplied by these filters, it would produce a higher score. This is for a simpler example, and then this is for a more complex example. Like as you see, there are multiple layers. The lower level layers have features which are not very abstract. These would be lines and the different patterns within those images. And the higher level layers, they have more abstract features. Like if you talk of faces, the higher level layers would learn to classify like the general structure of the face, like 2 dots over here, 1 vertical line is the nose, 1 horizontal line is the lip. And then the lower level layers would have more complex features, like the different detailed features of the face, the different lines, the different the textures, the maps, the more intricate parts of the image. And when we've trained the model, and then once the image is passed through the trained model, which is when the image passes through like this, each output of the previous layer is passed on to the input of the next layer. And this batch multiplication, when it happens, after the model is trained, it gives us the desired results. Let's say we're training to classify, let's say, a cat, whether an image has a cat or not. So we would have the features trained for cats, and the way we do that is we're going to feed the model. We're going to try out different models and what model is going to work best, which is the architecture of the model, which would mean how many nodes we need for the problem. And then we get a lot of images of cats, and then we say, okay, this image has a cat, this image doesn't have a cat, and then we would feed the model, and then our model would learn those features. And then if we visualize them, this is how our model weights would look. This is for a character recognition model. It classifies handwritten characters. This is for all the numeric characters. We can do the same thing for classifying cats, and those features would look like where the image would have features that denote that it is a cat. Those features would be of a higher value, and those images which don't resemble a cat, they would have a lower value. And then the model would learn those features, and then when we pass on the image of a cat into our model, it would tell us whether it's a cat or not. These are the different types of layers of such a model. Don't worry about all of this right now. These all in all are a set of 10 to 14 concepts that you can learn within 2 to 3 months. And the convolution layer helps to simplify the parts of the image, and so that it can be passed on to the next level of layers, which can learn more abstract features. Like, for example, this image is very high resolution, and there are a lot of features. Like if you talk of an array, if you draw a 3x3 array, 3 pixel by 3 pixel, it would not be able to surface the entire image. So it would pass on, so lower level layers would pass on the entire image and learn for lower level features. And then we use something known as convolution. We take a certain part of the image and then we simplify it, so that the higher level layers are more abstract and the model can look at it all at once. so that we can learn everything. We can learn the more detailed features, like there's the specific parts of the face, the textures, the more detailed parts, and the general overview of the image as well, which would be the 2 dots, 1 vertical line, 1 horizontal line. And then with our labeled data set, our model learns everything. These are the different layers that we've talked about. So all of these things, they are put together and a model is being made. We looked at a very simple model. This one, it has very few layers. The models that are actually applied in the industry, this is Inception V3 by Google. So they tried out they tried out different architectures, big ones, small ones, and this is one combination which worked out decently. And Inception is being used in Google Photos and other Google products, and you can use it for you can use Inception V3 too. They've made it open source, and as you can see, this has so many layers. The same layers that we explained, this has so many of them. When we talk of training, which means we're teaching our model to classify the features, we have a point where we started from. We start by randomly setting the value of these dots. And then we have to get the value of these dots adjusted to a point where when the image passes through these dots, passes through the model, we get the desired results. So training is the adjustment of all of these parameters. When we visualize this process of training, which means that we are at a point where we have to get all of those layers and the values adjusted so that when the desired image passes through, we get the right result, and our model is able to classify it correctly. We can visualize it. So let's say our training process started from here. We started with we have randomly just something positive and negative, just blue and red somewhere when we visualize our weights, and then we have to get it to the point of getting it to the most optimized range, which would mean adjusting the value of those filters to the way where it performs the highest when the images pass through it. And that is the process of training, getting all of those values from here to the absolute minimum. Sometimes our model gets stuck in a local minima, but our point is to get to the absolute minima, the lowest point, which is the best setting of values for our particular problem. When you have a different model, let's say when you change the model, your graph and all the possibilities of adjustment of the weights would be different. And in the background, it's all mathematics. But the point is, you don't need to learn the mathematics to be able to use it. So in a matter of just a few days, you can learn like how to get a model like Inception V3. You can go to GitHub, see Inception V3, get it, and then you can learn how to feed it with images, your own images, and then train it. And that one can do, if you know Python, you can learn how to do that in 2 weeks. So you can at least start building AI. And if you want to, you can get into the more detailed parts of how it works. And that is that also one can cover in up to 3 months. And the specific mathematical algorithm which powers the training, which we just saw, it's called backpropagation algorithm. One can understand it, but it's not required. And it's not as complex as it looks. If we look at machine learning as a whole, there are a lot of things in it. We just looked at supervised deep learning. And likewise, there are a lot of things that we do in machine learning, and we will go over a few of them.
All right, so that was a great example. We got to learn, we got to cover a lot of interesting things, right? And as Aryan said, what powers all of these algorithms is machine learning, right? So how does this image that you see on your screen right now is just an overview of all the different algorithms that exist with machine learning. So you have supervised learning, unsupervised learning, ensemble learning, neural networks and deep learning, and then reinforcement learning. Neural networks is generally the term that we hear most commonly, especially non-computer science people will kind of relate with that. Artificial neural networks is something that we hear off and on quite a bit. But all of this is what makes machine learning. So when we talk about classical machine learning, we'll just quickly go over a few concepts of machine learning, right? It's a subfield of artificial intelligence, as we kind of mentioned it before. And what it does is it's basically creating the building blocks that allows the computers to learn and to basically behave more intelligently and do all the processing that we were essentially talking about in our previous slides. So the terminologies that we end up using, some of these you've already heard, features, right? It's the distinct traits or the characteristics that describe each of the items in our data in a very quantitative manner, right? And then there are feature vectors. Feature extraction is something that we just talked about, right? We are looking at extracting a particular part of that data that we are interested in looking at. Going back to that horse picture that was there, there were certain elements in that picture that we were able to extract, focusing on if we wanted to look at the horse itself, the person in the picture, or the background, right? So now let's come to training and testing. So the data that we have, we generally end up dividing it into training and testing data.
And generally, we use a 80-20 rule, which means we have our training data set. If let's say we're classifying cats, it would be images containing cats and then a label. Okay, this has a cat, this has an image, and then a label cat, image, cat, image, cat. And then we would split it into a set of 80% for training and then 20% for testing. We use a testing data to when we're adjusting the values of the different nodes, when we are adjusting the values of the features that you just saw for zeros and ones, when we're adjusting them, we use 2 out of 10 images to run through the model and then compare it. Okay, it's like it passed through the image. This is where we have to get to, and this is where we are at. Our image of 0 is passed through it, but we're not getting 0. But then the label is this. So we have to get from that point to that point in adjusting the values so that our model is trained. So we use a split of 80 and 20, and we split it, and then we have a training and testing split to accomplish that. And this process of optimizing and changing the values of the different nodes and the different layers, that process is called training. And when we visualize it, the graph looks something like that. And we have to get to the minimum part, which is the best arrangement for those values. And then when you pass your data through your model, it performs the best. That is when the model is trained.
So what we have to kind of realize that when we're talking about the 80-20 division, both the training and testing data is coming from the same data set that you have collected. It is a part of the same data that you have obtained, and we are using 80% of that for training purposes and 20% for testing purposes to see how well our model performed. Now, when we're talking, also, I'm sorry, go ahead.
It's also for us to compare, let's say we use 20% of images which are 0 to test how, let's say we just started training. So our values would be somewhere else. We've just started training. It's not all the layers are not optimized for that particular model. Then we would be far away from the actual point. So we use this 20% of data to see where we are and where we have to get to, so that we can adjust all the parameters accordingly, so our model gets trained. And this adjustment of all of these weights, these parameters are called weights. This adjustment of all of these weights is called training. This is how a typical workflow would look like.
Right. So what you were just talking about, right? The training aspect, we're adjusting weights so that it kind of understands where it's supposed to be directed. So initially, when we do our training and do our testing, our results, or generally what you'll see in different articles, is the term accuracy is not as high. So the more data that we are able to train our model with, our machine learning algorithm with, the better is our accuracy when we test it with that 20% segment of our data.
These are the different categories of machine learning. You have supervised learning, you have unsupervised learning, semi-supervised learning, and reinforcement learning. Now we'll go over what these are. Supervised learning is when you have a labeled data set and you know what outcome you want. Let's say we want, the example of classifying zero or the example of classifying cats is that we know this is what our classifier has to head towards. That is supervised learning when we have a labeled data set.
Yes, so we have a labeled data set, cat images, that becomes a labeled data set and falls under supervised learning, right? Unsupervised learning. Now, the correct classes of our training data are not known. We have a bunch of data, we have images, but we don't know what each image contains, or it hasn't been labeled properly with a particular feature. So in that case, we utilize unsupervised learning.
Let's say, for example, we're working on a model that analyzes the tweets of, now the example has become Twitter or any other social media. And there could be anything, like there could be n number of terms that the user have mentioned. There could be new things that are out. Now, if you were to analyze the trends in different communities, that's unsupervised learning because we don't know what's out there. So we're just looking at what's out there and we're clustering them. We talked of clustering earlier. We're clustering them in different groups, and then our model is then seeing, okay, this is new, we can put them here, we can put them here, and that's unsupervised. That's our model functioning in an unsupervised fashion. We don't know what's the data is uncertain. It's not labeled. Then there is semi-supervised learning, which would be a combination of, imagine creating a hybrid between a supervised and an unsupervised model. Part of it is supervised, but then it also accepts new data, and then it deals and functions in uncertainty as well.
All right, the next one that we have is reinforcement learning. Now, this concept is a little different from, slightly different from what we've discussed so far. What we have is the term we are going to use is an agent, which learns from its environment, right? It's going to learn based on the feedback that the environment gives it. It's essentially exploring, right, a particular area to see what gives it positive feedback, what gives it negative feedback. And all of that is determined based on the policy. So if you look here, we have the agent that performs an action based on a certain policy, based on essentially rules that it may be working on. And then the environment based on that action gives a feedback based on which, whether it's a reward or not, the agent learns and modifies the policy a little bit to take its next set of actions.
Let's take an example of video games. How do you train AI in GTA to like shoot, like how do you train, let's say, police in GTA to shoot the character? To do that, there are rewards. Let's say so that character in the game is the agent. It's an actor, and it is put in an environment. And in that environment, it is given a set of rewards. So it is rewarded when it does a certain thing. So let's say the police in GTA is rewarded when it hits a criminal. Let's say if the stars are 2 and up, it has to shoot the criminal, and it gets the reward after 2 stars when it shoots the criminal, and it gets the most reward when it captures the criminal. So you're busted in GTA. So when you're in a fight, let's say with the police, the AI is trained such that it tries out many different things, and then certain actions are rewarded and certain actions are punished. So let's say for the police, shooting a civilian would be punished. So this algorithm is then deployed, and then there are multiple agents, and then they learn this way, and then a reward or a punishment is already defined. And then after the agent has functioned in that environment, this model derives a policy for the agent. That is the goal of reinforcement learning. So after all, when the developers are done, finish the game, and then you play the game, you see the police, they're performing the role that they should, which means their agent has derived a policy, and that is reinforcement learning. There are also other applications of this as well. Let's say we are optimizing the use of electricity in a factory. So turn on a particular machine at a particular time when there is load sharing, or when the goods have received from one machine to the other, when to turn it on, when to turn it off. And then we can reinforcement learning in different parameters can be applied there as well. That could be another practical example in the world. And likewise, reinforcement learning can apply to different applications. Video games are a big application of reinforcement learning.
So would you say that robots that are learning independent movement are working on reinforcement learning?
Yeah, a lot of robotic process automation uses reinforcement learning.
Which is really cool. So, I mean, what we're essentially trying to say here is that instead of just looking at these as, types of machine learning algorithms or how we classify them, we are also actually kind of trying to relate it with the applications that we're already seeing, right? There's a lot of robots that we are seeing that are moving independently based on the environment. If you've tried witnessing a Roomba, which is like that the mobile vacuum cleaner that moves around the house, it's a really easy to obtain application of reinforcement learning. Essentially, it detects if something is in front of it, learns from the environment, changes its angle of movement, and then proceeds to do what it needs to do. This is a prime example of how we are utilizing these types of algorithms in an application. So now let's move on to machine learning techniques, right? The different techniques that we're going to briefly talk about is classification, clustering, and regression. What we do want to kind of stress is there's a lot to learn with machine learning, but this is again, as we discussed before, this is something that can be covered very quickly and can be learned very quickly over internship programs, and we'll discuss that later as we get through the presentation. But now let's talk about classification, right? This is just a brief definition of that, but let's look at classification in particular. So what we do is we classify in a predefined category. So let's talk about documents, right? Documents you have, if you are opening any file, it can either be a text-based document, it can be an image-based document, right? This becomes a classification that we already utilize, that our brain automatically does. Right now, let's continue with another type of technique that we have, which is clustering. Now, how is this different from classification altogether? Classification was, we had a predefined category based on which we were analyzing our given data, right? So, and then we have clustering. In here, we do not have a predefined class. So whereas in classification, what was happening, we were training the program, we were building a model based on a training set for different categories. Categories could be anything, right? For a document-based one, it could be a PDF document, it could be a Word document, it could be an image-based document. It could be different classifications or predefined categories here. In clustering, however, there is no predefined category. So we tend to, what happens in clustering is we tend to have objects grouped together on based on certain keywords or characteristics that we have, right? For here, example, we have images that we can group together based on like keywords of man's shoes or other different things. Now, the most popular clustering methods that we discuss are generally, k-means clustering and hierarchical clustering. Now, these terms sound very complicated again, and sometimes it seems like it's going to be very difficult to learn, but these are actually things that are very intuitive. And the moment we start working with them, it becomes really, really easy to figure out. So now, let's get to k-means clustering. What k-means clustering is doing is essentially segments are all of our observations, the data that we have, into K clusters. K is essentially giving a specific number of clusters that it segments our data into, right? So here what you see on these graphs is we have on the left-hand side, which is showing all blue data, we have that the data is unclustered. It has not been grouped together based on our parameters, right? What you see on the right-hand side of the group of the image is the clustered data, which has two or three clusters here, shown here with blue, red, and green. The next one that we have is the hierarchical clustering, right? Now, this method brings along with it a hierarchy. So it has stages into it. It has two, generally we work with two strategies. The bottom-up approach, which essentially says that each observation, so all of this data that we have here essentially starts in its own cluster, right? And then pairs of clusters to work, merge together and then build up a hierarchy. So this type of hierarchical clustering is the bottom-up approach and is generally called as the agglomerative approach. Opposing that is the divisive approach, which of course is the top-down approach. So essentially, if we think about it, you have one cluster, and then all the observations are in that cluster, eventually dividing and splitting up into not necessarily each individual cluster, but based on their characteristics, would be grouped down into a greater number.
Then there is regression. Regression is basically statistics. We've studied it in school, mathematics, wherever. But the application of regression is in prediction. So when you model a particular parameter or any data, you can predict it. So the applications of regression would be in predictive maintenance or any predicting any factor of the data. Classification is different from regression.
Classification and regression, although part of ML techniques, they do offer different applications here, right? The classification aspect is to bring it all together. Just one second. The classification part brings to group the output into specific classes, right? The predefined categories that we have with our data. However, regression has the training data and it aims to predict an output value. This is a very basic difference that classification and regression have, right? Classification can be used to predict certain things. So here we've given the example of the type of a tumor, right? But we do have predefined categories here where we're going with, where we can classify the data as harmful or not harmful based on our training data. And so a very basic distinction comes here.
So all these three tasks that machine learning helps us to do, which are classification, clustering, and regression, prediction. These have their use cases. And these are also the building blocks for us to make artificial intelligence. Let's take an example of a robot in a factory. So it has to see a section of boxes. So it has to cluster them. Okay, so these are all the boxes, these are to be delivered. So it clusters them. Then it has to classify the box that it has to pick. Then when it's moving, it has to predict where people are walking so it doesn't have a collision with them. So all of these machine learning tasks with different machine learning models, and these machine learning models, when built and coming together, they make the whole aspect of artificial intelligence. A robot working in a factory doing all of these tasks, that's some intelligence that is now automated. Let's say we had to it's intelligence that is automated, and that's called AI. These are some of the use cases. These are used in email spam detection, machine translation, which would be Google Translate, Google Images, you search for similar images, Amazon's recommendation engine uses k-means clustering. It groups similar purchases, what other people have bought, so it clusters them and then it predicts you. And then Google News also use something to get publications from similar sources. When we talk of data, you got to get data, but you don't got to get data that's irrelevant. Or again, if you look at the horse image, you don't need the background, or you don't need a unnecessary dimensions of data in your data set. That would confuse your model. So you need more data, but you don't need irrelevant data, or you don't need data in dimensions you don't need. If you're trying to classify whether someone has diabetic retinopathy or not, which is whether they have diabetes or not, you don't need features which are irrelevant. Let's say the color of their hair or something like that. Those features would be irrelevant. So you need more data you need more relevant data, but you don't need irrelevant data.
Right. And within ML, and there exist a lot of techniques that essentially let you identify the amount of data that you would need, and classify the dimensions that become important for your design.
Another subset of machine learning is called natural language processing. These are all the language models that we've seen around, we've used, we've been around. Natural language processing is basically working with human language, understanding different languages, generating languages, classifying what's said, classifying what's written, breaking it down, understanding tasks, and all of the tasks that are to do with language. And it's called natural language processing. Natural language processing has two tasks: natural language understanding, which would be the breaking down of the different things that are said, identifying whether something is a proper noun or a common noun, and identifying, let's say you talk to Siri, you've given it a task, you've said, call Aryan. And so call is a verb and Aryan is a noun. So it says call is a predefined action, so it has to call. And so those are natural language tasks. And then there is natural language generation. Now, if you've seen on Gmail, it suggests you autocomplete suggestions. That's natural language generation. Soon AI is going to be able to write emails for you. And there are many applications of natural language models. There are chatbots and many others. You can generate entire pieces of text, entire emails can be generated for you. AI can, particularly for students, AI can help you do your homework. That's soon going to be there. So there's Openai, which is an organization headed by Elon Musk, and they made a model called GPT-3, and it's the world's largest language model. It cost them $6.5 million to train, and we were given the beta test in one of the initial batches, and we've been trying it out. And likewise, there are other language models in the domain too, and this is soon going to be a reality. Drafting of things, copywriting, AI is going to be there.
So the application that we're constantly seeing is, would you say, in chatbots? Like a majority of the websites these days have chatbots in them. That is all natural language processing.
Mm-hmm. Yep. And then these chatbots are trained in different ways. They're trained with different data. Which is why you see they have different personalities and they do different tasks.
Absolutely. I think the most common one that people have interacted with is probably Siri and Alexa. And but we are commonly, we are interacting with other levels of chatbots as well. If you log into majority of customer service for any of the online retailers, you get to interact with their respective chatbot.
Mm-hmm. Mm-hmm.
Yeah.
Yes. And then there are useful ML libraries which help you to accomplish all of these tasks that we talked about earlier. So for computer vision, you have OpenCV and you have Python imaging library. So these help you to do a lot of computer vision tasks like drawing bounding boxes and faces, or processing images for the training of your model, or doing certain tasks to the image. And for natural language, you have Natural Language Toolkit, NLTK in Python, Spacey, and Jensen. Natural Language Toolkit helps you to break the sentence down to the parts of speech tagging and help you do the verb and noun segmentation. And then Jensen, when you talk of a large language model, Siri knows the relation between things. So it knows that, okay, your YouTube has these actions, and this is all you can do. And it can also understand queries, and then it can search for them. If you ask it, how tall is the Qutub Minar, or then it understands what it is. So it represents everything on a vector map. So you can represent all of these things two-dimensionally, and then these language models operate. Even GPT-3 is structured that way. And then Jensen helps you to get that vector map and make that vector map. Yes, your questions are welcome. Your questions are welcome. You can send them. Then you might have also heard about the term called big data. What is it about? So basically, big data is the problem when you have so much data which is being generated that you can't store it on a single device or even a single server. And then you have to store it on in a distributed fashion on the cloud and on in different data centers. And then how do you manage that? And then how do you, the goal of storing that much data is to get insights from the data. Google stores so much data, and then it makes products which are helpful to the people by understanding and getting insight from all the data. All the companies are storing customer data to understand their customers better and then make their products better. Like, for example, Google, it takes in the usage pattern of their users, and then it improves their products. It also creates products out of the data that it has stored. So it has all the search and all the articles indexed, and then it created Google News, which compiles these different news articles so that people can read it from one place. That is the data it has seen from all those users, and it has created a model which Google has put in Google News, and then Google News is now a product which has come out of looking at so much data. If we talk of how we deploy our models, we've so far talked of understanding our data, making a model out of it, the different tools we can use to make models with, and everything. We now come to deployment. Deployment, traditionally we used to have servers. Now we have cloud hosting services, and we'll go over what the difference is. You have different services operating at different levels. You can have your database and models deployed in Firebase, which is like backend as a service, or you can rent out different server architectures, which is infrastructure as a service. There's also platform as a service, and then these allow you to serve your models on the cloud. We'll talk of how different models are in different industry models are being hosted. There's something known as Docker, and Docker allows you to containerize your models. This is Docker. And the difference is previously when we used to have different server, different individually pre-designed servers, we used to have them on virtual machines, and then each virtual machine would run an operating system, and then the libraries that the code needs for that particular app, and then the app itself or the machine learning model. Now with Docker and containerization, you have one operating system, and then you can have n number of containers and with their own libraries on top of it. And then with Docker, you also have containerization. So your model can scale on the cloud, and it can dynamically change its location, dynamically change how many computers that it goes on to. So this is different between a traditional server and putting something on the cloud. You don't have to repeat the operating system in each of the virtual machine. You have one operating system, and then you have Docker containers placed on top of it. There are many examples of apps running on Docker, and this is let's look at one example of where these apps are put. Cloud hosting services are going to be big, and why we talk of the cloud when we talk of machine learning is that because these models are so large that they can't run on one server, so they have to dynamically switch their location between different services, different locations, servers in different locations. And also, we don't store them on the user's mobile devices, because these models, let's say a model is 3 GB, you don't want your users to store them on your device. No one's going to download 3 gigs for your apps. Also, the average number of apps that a user uses, those have also been like, people generally use 5 to 6 apps. After 2015, it's been like that. So you put your model on the cloud. This is one example. This is one of our projects deployed on the cloud, and you can see this is how Google Cloud Platform looks when you've deployed your project. So you containerize it with Docker and you put it there, and then you create an API so that your web interface or your mobile app can talk to your AI model. And this is we use the compute engine for that, and this is the model deployed over there. You can also use storage for storing your data over there. As you're generating more data, you can keep it over there and then use it. You can also use it for learning. There are a lot of things you can do with it. Now we'll touch upon how AI is being utilized in different sectors. These are the different job profiles in artificial intelligence. There's big data engineer, there's data scientist, there's data engineer, there's ML engineer, there's product manager. These people handle different roles. Data scientist can mean everything from the one who just visualizes the data to the one who also derives intelligence and insight from the data. There's ML engineer, who's the person who's in charge of making the models, choosing the architecture, choosing the frameworks. And there's the product manager, which sees the integration of the AI models in different products and how it applies to like a product which is sent out to customers. There is an AI research scientist, which works on the different research instances in artificial intelligence, improves the research in different fields, researches to make better model architectures, experiments with things, and so on. There are many job profiles in artificial intelligence.
All right. So before we continue on with that, there was a question in the chat about, whether you can ask your questions here. So yes, please just keep putting your questions into our chat box, and we'll get to it actually pretty quickly here. All right. So coming back to our job profiles in artificial intelligence, right? Let's talk about healthcare. Now, healthcare is a very, very important aspect of all of our lives, right? So where can we see artificial intelligence being applied? There are some very obvious cases. We talk about, diagnosis and treatment. We talk about, precision medicine in genomics. Although genomics is not a very common application that we think about, we can also see artificial intelligence being applied in the hospital workflows, right? How can that be done? We can talk about patient flow optimizations. The data for each patient can be centralized and can be available so that our artificial intelligence algorithms can actually access that data quickly and kind of relate it with any pre-existing conditions that they may have, or predict any future issues that may occur, future diseases that may be contracted based on their previous ailments.
Mm-hmm. And likewise, there are so many applications within healthcare itself. Let's say looking at the data of your past, of your disease classifications, the last 10 years or 20 years of your entire lifetime, and then seeing whether there are repeated conditions, and then comparing that with the data of other patients and what conditions they've developed, and then predicting what are you likely to get, and then seeing what doctors have cured what diseases, and then matching patients and doctors using machine learning and seeing what types of conditions that the doctor has handled. There's also AI tools are also helping doctors in the cleaning up of data. Let's say someone is a radiologist. There are so many data points. Let's say in an MRI scan that a doctor doesn't need to look at, AI is already helping doctors to clean up the data and look at the relevant features. And also soon creation of different products that help users better treat their conditions. Let's say an app that looks at your acne and then suggests you, okay, you need to drink more water, or you need to you have a particular type of acne because XYZ. So all of that AI can take care of. We can use computer vision, and we can classify based on sensory data as well. Let's say electrocardiograph or the heart rate or something else. And all of these in conjunction, a lot of healthcare applications of artificial intelligence are there. Okay, there are a few questions.
Yes, so I think we'll take because since a lot of the questions are essentially on a very similar topic, maybe we can kind of address it first. Yeah, so the most common question we are getting right now is regarding our internship program, right? We have a question from Mr. Naveen Jain asking how students can associate with our lab and what type of skill they should have in order to associate with us. Then we also have a question regarding how long our internship program is, and how somebody living internationally. We have Ms. Fatima Al-Ahmed asking how she can join the internship program from Abu Dhabi. So let's quickly jump over to our internship program and kind of discuss that first.
Yes. So this is our internship program, and it's a way for us to find good and interested people who want to learn and whom we can work with. And so let's address the questions straight away. How can I associate with type of skill? Okay, if you're a second and third year student, you're fresher, the only thing that you require, all of the things that we just showed you, we can teach you that in a matter of 2 to 3 months. And then for an internship program, you just need to have the will to learn and the time to devote to a program. So the internship program is going to be at TensaX Innovation Lab in Jaipur. And you just got to be willing to learn these things, and you should have the energy and the zeal for and the energy to learn these things, and then we'll take care of the rest.
So what I would like to kind of add to that is the TensaX Innovation Labs are within Jaipur. If you're applying from Jaipur, the labs are close to the airport, and you would be training here in person, of course, with all necessary COVID precautions in place. So yeah, as Aryan said, you have to have the will to learn. If you feel that you don't currently have the skills to become an AI developer, that's the whole point of the internship, is for you to learn and to apply. So so that's what we try to do here at this our internship program. Now, talking about the internship, I'm going to hand it over back to Aryan.
Yes, so I'll address the questions straight away. How much skills do you need? So, well, if you know Python, that's great. We can take care of all the things. I can share the example of Amrinderji, who recently joined. He learned Python in 3 days. Now he's on to machine learning, and he would very soon be able to build these models that we showed and we are talking about. He'll be able to work with them. And okay, hello, I am from Jaipur. I'm interested. How can you? Okay, as you've applied for the you filled the form for the Learn and Grow program, and we will call you for the interview. You can.
We do have a very specific, actually, we have a couple of questions asking about interns that want to join internationally. And yes, I think that's a very great question to ask, because we have a participant, we have more than one participant asking that that question. So how can we get our interns integrated internationally?
So we are soon going to roll out a platform through which all of this can happen online, where the different materials we can share with you online, you learn them, you go through them, and you can work on projects. We believe that learning, actually, it's not theoretical, it happens through projects. That's how we've seen what works best for all the internship programs. It's just more hands-on, intuitive, and practical. So we're coming up with a platform to get that started, and in the meantime, we'll have your names there, and you'll be taken care of. It's soon going to roll out, and you're a part of it, I can tell you that.
So one question that we are getting is how to apply for the internship. So when you've actually registered for this event, there was a question that kind of asked whether you wanted to enroll for the internship program. One option is that you click yes on that, and we will automatically get in touch with you regarding the internship opportunity in the next week or so. If you accidentally did not end up clicking yes to that question, please feel free to drop us a message on our mail ID through which you would have received this link for joining today, and we will get in touch with you. Just feel free to do it either way, and the link to join our program is also available on our website, so you can approach that as well.
Some more questions?
Yes.
Is it online or offline? At the moment, it's offline. It's all of the people who are interested, we're going to do it online, and it would happen very soon. And you're going to receive an email, and we'll take care of it. Another question, talking about Mr. Aryan, since you mentioned you studied at Stanford University. Okay, so I looked at TensorFlow, which it had just came out, and the people that I was with, undergraduate students, they were working on it. And so I started learning TensorFlow over there. And then when I was at MIT, that's when I actually saw projects. Nothing was happening in India. And so 2017 was when I started getting into TensorFlow, started making projects, learning about things. 2018 was when I worked on projects. So I saw at CCEL, there were a lot of projects going on. There was a project going on with Toyota with self-driving cars. I actually worked with Hal Abelson, who's a professor. He coined the term open source. And even in my course, we pivoted a lot, but with my friends, we explored making different image classification models. And also we worked on we made a 3D CAD design, and then we also explored this application of architecture. It was also a lot of theory, but yeah, it was a good experience. Yeah, the session, we can talk of the different applications still, but I'll at first address the questions here. Okay, I live in Abu Dhabi and interested. By the way, this year I spent quite a lot of time in Dubai, and we have our presence in the UAE as well. And the UAE government is doing a lot of things in artificial intelligence. They're actually quite ahead. They have their programs. They're already automating different processes, and that change is soon going to come to other places as well. Yeah.
So there's been a couple of questions. So what I would like to stress here is that for all the international applicants that are interested in joining our internship program, do email us and let us know so that we have your email shortlisted for when we launch our platform. And also there's been a couple of questions regarding the recording for this session. And yes, the recording for this session will be available on our YouTube channel, and you will be able to access that starting tomorrow or at the earliest, So you can definitely view this seminar as well as our previous versions on our YouTube channel.
Now, talking about the skills that we mentioned, we've had many versions and many runs of this internship program. We've been doing this this picture, I think, is from late 2018 or 2019. So we've seen that regular second, third year students, the only prerequisite is the commitment to learning and the wanting to learn from your side. That's all. Now, we've seen that in 3 months, they can be trained ML and AI engineers. They're working on projects, and we've trained our team on our own. And I can show you some of our projects that we built at the lab in Jaipur. This is workflow automation, summarizing of letters and document into simple tasks. We also we also worked a lot on a lot of natural language models. Okay, this is one interesting project where we made the world's highest performing. It's still the world's highest performing facial micro expression recognition model, and we made these 5 models that understand human feedback. They understand human emotion. So if, let's say, it's placed at an event, it would look at the facial expressions, the body language, the speech, the voice tonality, and what's being said. So if someone said, okay, the food was okay, the speakers were awesome, the event was good, it would take all of these things out and it would contextually do that. So we work on a lot of projects like that at TensaX Innovation Lab, a lot of AI projects. And this was this making of the world's highest performing facial microexpression recognition model was with our team trained in-house at TensaX Innovation Lab, and 2 of them actually were interns whom we had picked up from colleges, and who were selected for the program. So this is the internship program, and people who are in Jaipur, they can apply right now, and we will contact you if you filled yes on the form. And people who are at other places or internationally, we would get in touch with you. We are soon going to roll out an online program where all of this, all of the development of skills, the making of projects, the learning through projects, and the internship program is also a program where we look for people who we can work with, within the internship program and beyond. So we'll get in touch with you and we'll send you an email about the online program we're soon going to roll out. And it's going to be similar to what we do at the lab, and you'd be connected with us, and there'd be an online portal where you can work on projects. And also after the internship program, you get work credits. So all the projects that you worked on, the tasks that you did, you get your internship certificate, of course, and then after completion of the internship program, you get your work credits. So all the tasks that you did, what roles you played, what stage was the project in, and what stage did it got to, you get that, so that you can put it on your resume and show it where you need to. And we would have this whole thing operating online as well. And stay tuned for the online program. We'll send you an email.
There's also another thing is that, when you start, the place where you learn is where, you want to stay associated with. So what we would also like to let you know is that our team, it's not just about associating with us for the internship program, it's staying associated with us. Our team stays, connected with our interns for any future projects that they are working on as well on artificial intelligence. And we have examples of previous interns that are currently working on other projects and are associated with us. So it's not just a matter of a short duration that you would be working with us. It's a long-term association, even after you finish your internship here and are working in a job. There was another question here regarding the duration of the internship, like how long our internship programs are.
Yeah, it depends on the projects that you're working on. So let's take an example of Amrinder ji. He has a medical background, so he's working on a project that has a medical backend, and so on. If you're a computer science student, like the internship program, generally it's considered in between 3 to up to 6 months. It can stretch up to 3 months, to up to 6 months. But the Learn and Grow program it's not like you just intern with us and then that's all. You stay connected with us. Like for any work opportunities that we have in the future, we let you know new technologies that are having. We send you an email. Any conference that we are holding, that we've planned, we'll send you an email. So you stay connected with us anytime. And then the primary objective is that we're looking for people who can work with us. People who can. We take care of the entire skilling, the entire training of the people who are selected for the program, and then we've had many people working with us from the internship programs that we've had since, and I think because in machine learning everyone is on the same page. Even at Stanford or MIT updates their courses every 3 months. In India, we're not doing anything like that. We're teaching frameworks which are obsolete. We're not teaching AI. We're not teaching like practical frameworks and the things that build AI. So we started this internship program to strengthen our team, to grow our team, because we need to grow our team. We need like more people who work on projects, and it's a great experience overall, the internship program. We enjoy the internship program like thoroughly. There's the learning of skills. It's also an enjoyable experience to have interns. Our office is also a pleasant space to like work in. People working in Jaipur, and people who are interested, I would love to talk to you. We'll have you there at the office, and then we can talk about what works with you and like how much time you can devote to such a program. Are you willing to learn, and what are the things that you're building? Also, if we can also guide you to, we can send you links to the things you can learn. And let's say you're just looking for the things to do when starting out in ML, you can we can tell you that too.
As part of the Learn and Innovate program, we do roll out this information, as Arun is mentioning. We do share the information on how to get started with artificial intelligence. And all of that information is going to go out to you as, as you've already signed up for these webinars. And yeah, this information is going to be available to you very, very quickly and very shortly, right? And so with all of this in place, we also would like to stress that those who are visiting our offices, I know there was a query that came in regarding COVID precautions. So we'll again stress this, is that our office takes proper necessary COVID precautions. Please understand the health safety is very important in every aspect. So our offices are fully working under COVID precaution guidelines. So feel free to message us and kind of schedule an appointment if you would like to visit the lab, or we'll get in touch with you if you've already selected the internship aspect on our sign up form.
And yeah, that's it. It was great talking to you today. And any query that you may have regarding anything, you can reach out to us. You can send us an email or reach out to us on our social media or anywhere, or you can schedule an appointment if you like to see the lab and talk to us at the lab about the internship program or the different things that you'd like to start out. You can schedule an appointment and come see us at the lab, and that's it. We both enjoyed interacting with you today, and we'd love to stay in touch with you and interact with you more in the future.
Absolutely. And yeah, just feel free to message us at business@tensax.com, or follow us on our social media pages on Facebook or Instagram or LinkedIn, especially, just connect with our professional network. And we'll be able to answer any questions that you may have regarding the internship program or artificial intelligence in general. All right. So before we sign off for today's session, we'd just like to kind of quickly let you know that we have another webinar that is on Monday, July 19th, for artificial intelligence for startups. So if you're interested in that, just get in touch with us and we'll let you know about the details.
Yes.
All right. It has been an absolute, fun time interacting with everyone. We've both had a great time. Thank you so much for joining us today.